Thank you so much, Hannah. Thank you to all of the speakers. Well, we've got a couple more talks before the next coffee break. But I know that, mid-afternoon, we've got this soporific dark room, wonderful lights around us that lull us into a sense of sleep. So if you want to stand up and just have a stretch, feel free. Just move and make sure your brain is associated with your body. Please do stand up. Thank you for even running out the door. Well, I didn't want that. No, but I just want to make sure that you're really sharply focused for the next two speeches, because we're going to now have two talks. Title is Introduction to Multidisciplinary Outlook of a Future Using Space Resources. And the first person to speak is Erik, Kulu, who's the founder of Factories in Space, Maleri Space Energy. His talk is entitled Economically Sustainable Industries in Space, Future Visions and Genesis. So please welcome him to the stage.
Hello, yes, I'm Erik, and my background and day job is technical, but I have also curated the Factories in Space database for over 6 years. So my talk is about more generically about future visions and the early beginnings of the future space industries. So Factories in Space is a database of commercial entities in the in-space economy, space resources, and microgravity manufacturing fields. It's growing quickly with over 900 entries, and in-space economy is the new extraterrestrial space industries. It has many names, such as space-based economy, LEO economy, and it also includes cislunar economy and Moon and Mars economies. But briefly, let's see how in-space economy is doing. So first, I have defined this 10-category high-level taxonomy: human spaceflight, cargo transportation, surface spacecraft, space stations, surface habitats, in-space manufacturing, space resources, space utilities, and in-space transportation, plus miscellaneous. And then those 900 entries are sorted here by those categories. So human spaceflight, surface spacecraft, and space stations are obviously quite difficult and capital intensive, so not many companies STEM. Surface spacecraft are really being held back by the lander delays, so hopefully we'll start to see them launching soon. We already have some cargo transportation and in-space transportation companies active. And then in-space manufacturing is the largest category, and we have many demonstrations there, but none are actively occurring yet. But first, so where do we actually want to get to? What's the vision for in-space economy in 2050, and hopefully even earlier? So we want to get to this. So bustling multidisciplinary activities all across the solar system, near Earth, on Moon, on Mars, factories in space, uniting space solar power, space resources, in-space manufacturing. This is the world we want to get to, because that will enable much faster solar system exploration, settlement, and drive the development of exciting new space technologies. But why is this important, and what are some of the challenges? So I strongly believe that humankind settling space will help to solve some of the biggest problems here. It will create the technologies, and it will change us through like overview effect, through having common positive goals, breaking the zero-sum bias, and so on. For example, if you had abundant, cheap green energy, we could do carbon capture, vertical farming, water desalination right away everywhere. Or there is this idea of moving most heavy manufacturing to space, because in space there is no life, so, and it's already full of planetary formation debris and radiation, so the definition of pollution will have to be redefined in space. And that would help to really decrease the environmental impact of manufacturing to Earth significantly. We also need new reasons to go to space. We need new economic drivers for spaceflight. The government budgets probably won't increase much, so we need something bigger than existing industries like telecommunications. That's the missing piece to speed up development, to get to that exciting Star Trek-like future. Space has been compared to gold rush, but not many picks and axes will be sold until we find that gold in space, or also known as killer app. And space has also been compared to railways, but railways were built where it made sense because of people, activities, and resources. They weren't built to almost nowhere. So profit is a word that many people don't seem to like, but it does enable a lot of R&D, and a lot of our modern comforts are here thanks to profit. Space also has a problem with very optimistic forecasts, and alternatively, very pessimistic forecasts. But what we need is realistic. So for example, you probably all heard that space economy is about 500 billion industry, growing to 1 trillion by 2040, but most of that is not actually space. The real space of making satellites, launching them, remote sensing, that's at best up to like 100 billion total. And so we need those realistic numbers also, so we could take the necessary steps to actually get to that future. And we also have the chicken and egg problem that also came up yesterday. So a typical example is with asteroid mining. So even if a company raises billions of dollars to make asteroid mining happen at large scale, the customers wouldn't appear for many years, if not decades, especially in space, maybe on Earth, but haven't seen proper techno-economic studies to prove it. But without those resources, of course, the ecosystem and supply chain will also not develop. So, and overall, we are still lacking the financially stable customers across the board. And something furthermore, completely new markets tend to grow very slowly, which is unfortunately something that a lot of startups don't think about. So thus, we do need those gradual approaches that have been talked about a lot yesterday, but we also need those large existing markets that we should try to supply from space, assuming we can do it better. So what might be the first steps then? Here are some of the ways I've been thinking about it. So here we have the Gartner hype cycle methodology, but populated with the in-space economy fields. And the color shows the time to get to the plateau where basically the company is financially sustainable. So for many in-space economy fields, the time will be very long, 10, 20 years. And for many, the hype hasn't even started yet. It will likely start once Starship is flying more regularly and we land humans back to the moon. And second point I wanted to make here is that in new space, the amount of startups in a field and their funding and their news about them, it's very rarely correlated to actual market demand. Only sometimes correlated to the market opportunity. It's mostly just hype. And it's important to think about it because we need more people and we need more resources going into the fields that are more likely to actually become very big industries and help everything along. Another way of looking at it is market sizes versus timelines. So on the horizontal axis, we have small market to distant market, or existing market to distant market, and then vertically small market to large market. And of course, this changes in time, so it's more about the present moment snapshot. But let's say if you take space stocks, orbital transfer vehicles, it is an existing market, many companies active. But if you look at like momentous financials, they're unfortunately doing quite badly. So it's clearly a small market and very difficult to make the unit economics work. We can take in-space construction. Easy to imagine that it will be a huge industry in the future, but probably quite distant future. But then we have space solar power. So energy and electricity are a huge market already now on Earth. If you built it tomorrow, the market would be there. Of course, it's challenging and most people are still skeptical about it, but we really have to try. We don't have many better ideas how to make economically sustainable big space businesses. So where we have at least theoretical chance, we should really try. Something I've been also thinking about is since the ancient times, we had Silk Road and then we had spice trade. But spices, coffee, tea, these are luxury novelty products. They are not needed for human survival. They don't have any industrial use, but they basically kickstarted the world economy, especially once it moved our ships. So perhaps a more ethical version of spice trade will also happen for space or in space and kick off that sustainable space economy. space beer, chocolate made in space, diamonds made in space. Some people really don't like this approach, but that's our history, and that's how actually most businesses work. So here, let's assume we find that killer app or the space gold. We have, and how would that then kickstart the flywheel or snowball effect, and how would that get past the chicken and egg problem? So let's say we have a space solar satellite in orbit, or we have a product or material that we can do in microgravity profitably. Initially, I believe that we would launch materials from Earth, and then the markets would also be from Earth. But now, when we have this kind of new economic activity and revenue in space, then let's say a startup can bring some resource cheaper from an asteroid or through recycling. That's basically an immediate market for them that already exists at that time. And the numbers would be very clear of what they need to achieve. And from there, we can see more and more space markets arising. Once we have many killer apps, we can easily see resources coming from the asteroids, from the moon, through recycling. But at the core is still something that does generate revenue and hopefully also profit. That's something that's economically sustainable. Here's a teaser about roadmap infographic I'm also working on. Yeah, it's impossible to read, but the idea is that there actually has been a lot of activity in in-space manufacturing since even late 60s. But a lot of those forecasts haven't happened either. But then I also intend to populate them with future announced milestones and also some forecasts where we might figure out those killer apps and how everything will hopefully grow very fast. So basically, to conclude, there are two scenarios and two paths. One is the slow growth path, where we basically have been on for many decades, where we primarily have government funding, and then slowly, government starts to buy services like resupply, lunar landers, space stations. And then on the side, slowly, we have some pure business-to-business activities also. But hopefully in the next 3 to 5 years, we'll actually discover some of those killer apps or space gold, which will put us on a new flywheel path where things will speed up significantly and the world will get much more exciting. So what might be some of those flywheel industries? Perhaps that novelty luxury product made in space, perhaps a unique advanced material made in space. Semiconductors and pharmaceuticals are a really hot topic recently. Let's see if they are hype or there is substance in them. Maybe helium-free. I've been really skeptical because it's not a blocker for fusion, but perhaps Interloon is really onto something with that. And then I would put my biggest bet on space solar power, because really the market is there now, it's huge, it solves actual problems, and it has a great positive purpose. And that's all. Please see my websites and papers for much more content, and thank you.
Thank you very much, Erik. Thank you. Well, lots of ideas there to dream about tonight. Any questions in the room? Yes, we have quite a few hands, in fact. So if we have quick questions, we've got one here, one over there as well. Looking at all sides. Oh, and Robert.
Okay, thank you very much for this brilliant talk and all your excellent work. So I'm Maarten Roes, planetary scientist. I'm just wondering about the graph you showed with the time and the markets, or the small, large market and time. So I saw on the distant side, small markets, the recycling or cleaning up of LEO, basically. I was under the impression that was, I don't know what distant means for you, how many years that is, but I was under the impression that that would be a big actual problem to solve, and it's quite on the edge of happening, or is that not really so?
Yeah, it's considered a big problem, but it's really hard to see actual markets there. So governments are investing in demonstration missions, but we haven't seen any commercial customer actually having to do active debris removal. And then recycling, I think, is a bit further away because that needs a big supply chain to make it worthwhile.
Okay, thank you very much. And I'll be growing tea on the moon, by the way. So you might add tea to the beer wine there. So thank you.
We had a poster on this last night, and in fact, removing the debris is one of the points that I've made as well. We have a couple more questions. I mean, you showed perhaps in your last slide that if you had unlimited funds, unlimited amounts of money, where would you start your SME?
Yeah, I think it's, to my best knowledge, it will be space solar power.
Solar power, okay.
Space solar power, yes.
So Mana Electric are on a good...
Maybe something else, but I leave that to others. So would be very interesting to know if someone else has better ideas.
Okay, there was another question this side, right over there. Yeah. Hand over here. If a mic can go to him. Meanwhile, Robert can ask his question.
Okay, Erik, very nice thought. Thank you. In the 90s, or beginning of the 90s, the ISS was sold as we can do mass production on board the ISS. We're going to fly scanning electron microscopes. We have a lab supporting production. It didn't happen. Now I see again the pharma business coming up in this respect. I hear this more and more, and coming from my own experience, I'm slightly skeptical. So how much substance is behind that?
I'm a bit skeptical too. Yes, it does repeat. Like in-space manufacturing had the first wave in like late 70s and 80s when they wanted to do semiconductors and did many pharmaceutical tests. It might be a repeat, but I hope that with further decreasing launch costs, perhaps the probabilities are higher. Yes.
It should be on, yeah.
Hi, my name is Simon Drake. I run two companies, Space Ventures Investors and Lunar Resources Registry. So there's two key words in the titles of those companies, Space Ventures Investors. I actively look for what drives space investors. And with the Lunar Resources Registry, yes, we are looking for gold on the moon. But back to space reality, what you're talking about, which I really appreciate the data you've got. Do you think that on Earth there is an abundance of distractions that we get stuck with and interested in that stop us from really pursuing space as an economic objective?
That's a great point and great question. Perhaps, but I think even in space, we probably get distracted by lower hanging fruits while we should focus on bigger problems and more likely to be bigger markets.
Thank you.
Thank you, Simon. I just wanted to ask Matthias, when you were talking about the Silk Roads and our treats, what do you think would be the biggest treat you would have wished for? Alcohol in space is a market. There we go. Well, we've got a bit of that coming later since you're back on Earth. Thank you very much, Erik. Thank you. Next, please welcome to the stage Hemanth Kumar Madakashira, who is a systems engineer at Space Application Services, and the talk is entitled Future Ground-Based Pilot Plant.
Good afternoon. I am Hemanth Madakashira. I am systems engineer and project manager at Space Application Services. We are based in Belgium, and I'm here to spread the word called GPPP, which is Ground-Based Pilot Plant. And the project is initiated by ESA, and we are the prime contractor, and we have a notable players in our consortium that you can see in the slide. Yeah. So before we dig into what GPPP is, or ground-based pilot plant, maybe we need to know why we need a ground-based pilot plant. So in line with the global exploration roadmap, and in specific in the context of longer duration and increased utilization, an operational pilot plant is foreseen along with a long duration habitation on lunar surface. And the scale of the operational ISRO plant is aimed to provide 45 tons of oxygen generation per year, and that is to meet not only for the crew but also for the propulsion needs. So that's a long-term goal of a roadmap. And coming back to the current stance on the ISRO process, currently we are at the stage of developing breadboards, which is you can see at the leftmost side on the next to the Earth planet. On the Earth, we are trying to make breadboards to validate or raise the TRL of the is to demonstration model, which is to and then once we have a demonstration at we have a raised ARL, then we can launch the system, make it work on demonstrate on the lunar surface. And here we are talking about a scale which is production of about 100 grams of oxygen. This is just a demonstration model, and it is to demonstrate a generation of 100 grams over a month period or 14 days. So why, now we can say why GPPP? It is a common practice in chemical industry and as well as in mining industry. Before they go very big, they always test with the pilot plants. And the pilot plant here is not only to aiming at a higher scale, because if we increase the scale, it's not just increasing the size of the equipment. We need to change the complete technology. We need to see how to operate the plant in a different way. So it's that one aspect, and as well as the sustainability aspect, because if you would launch 1,000 kilograms of payload and we produce less than 1,000 kilograms of oxygen, maybe it is not viable. So the viability is also one of the key things, and that is why we have ISRO pilot plant. And the ground-based pilot plant is to see what technologies can be used, to learn on the ground prototype how the systems we can depict that could be for the lunar pilot plant, and to see how we can operate for the long durations, learn about it, whether there will be a lot of maintenance activities, how to deal with this, all those aspects. So our project, ground-based pilot plant, I think is aimed to scale up the production, add more subsystems that defines the sustainability and long-term operations, and to demonstrate a production rate of about 400 to 700 kilograms per year. Yes, that's kilograms. So what are the objectives of GPPP? So the main objectives of GPPP or ground-based pilot plant is to mimic to act as an analog to the lunar pilot plant, to learn all the operational aspects. How can we scale up the plant? How can we integrate several subsystems or several equipment, new technologies, and all and so. And not only that, the third point there is about open platform, which is one of the key things, because now we are talking about in the time frame of 5 to 10 years. And if we take a technology now, it could be completely different technology, or a better performing technology could appear in 5 to 10 years. So we are working with an open platform technology in such a way that any subsystem or any equipment could be integrated into the system, into the GPPP, ground-based pilot plant, and to be validated to see whether the performance increases, to see if, how it reacts with other subsystems, and so on. And the final one is, here actually. The final one is to install the plant and make it operate at Erik, and to make the plant as part of one of the Erik facilities. That's one of the key things that we would like to see. So I'll straight away jump to the next slide, which is about what the system is about. If you pick that the facility is centric, then we have several actors acting on it. ESA is asking, how can we utilize it? How can we do the research on it? And Erik could say, how could we operate them? And how could we engage the users? And likewise, one of the key aspects which I would like to focus in this slide is users. You can see users or developers, they interact with the plant by providing new technologies. It could be a technology that is a very high temperature operating thermal sensor, a very simple one. But if they would like to validate such a sensor in a relevant environment, we have a facility which is an open platform facility that could integrate new technologies, and they could validate their results and probably also integrate into the system itself. And so during the course of project, we already performed a stakeholder engagement. We collected over 170 information on 170 stakeholders, as part of the study, and we covered several actors from space industry, mining industry, universities, research organizations, and research facilities. And based on the identified stakeholders, a target approach has been developed in perceiving the stakeholder engagement itself. And that is to initially an online communication was established where we have depicted, as we see in the image, a high-level overview of what a ground-based pilot plant could be. It's just a blocks. It can be anything. We would like to show only the functions to the users so that they could let us know what they want to integrate into the system and how they would like to test or validate their system or equipment or subsystem into GPPP. And furthermore, a subset of the stakeholders were targeted and only a survey was performed to identify expectations of the community. And at last, in-depth interviews are conducted with a critical group. We identified only a final group, a critical group, where they could provide more details and say how stakeholders would like to interact with the future GPPP facility. So today we have seen, right from the morning, we have seen several presentations, and that they are covering topics, very wide topics. Some topics could be with the beneficiation techniques. Some topics are about the payloads, some sensors, measuring the content of the water or of gas, measuring XR of XRDs. So we would like to see such a payload, such a system or equipment to be integrated into GPPP and test for future subjects, test as future subjects. Actually, I would like to also take, in practice, there should be a session in Space Resource Week to be able to get the feedback from the users or from the attendees, but we have the timeline did not match properly, but I would like to take the opportunity to ask you all feedback on the GPPP or ground-based pilot plant, and in terms of how you see, how we portray a ground-based pilot plant, and what, maybe by saying what are your technologies or what are your processes that you would like to integrate into such a big system, and how would you like to test or integrate with such a facility. So I repeat, what is your technology and how would you like to integrate into the system? If you can provide this information either via email or via chat message, that will be very nice. And we would like to use this information and feed into our user requirements. So, yeah, please, any questions?
Thank you so much. I think everyone is in need of a coffee, but we must offer you the chance of a question if there are any questions in the room. I can't see. I think, unfortunately, the coffee beckons. Thank you so much. Thank you.
Yeah,
30 minutes for coffee. We have a memorandum of understanding being signed between Erik and Offworld, so do congratulate them as well. Thank you. 30 minutes.